Well, this is just a quick kind of helping you get started on the stoichiometry test review. I'm going to begin here with what I call the MVP of chemistry, a conversion triangle, where the mole is the most valuable player, the MVP, with M standing for mass in grams. A lot of times we'll start with grams. Over here, P stands for particles. And that's either going to be if you're looking for number of atoms or molecules. Over here, the V, that's going to be for volume. And that's going to be in liters. Now, whenever you are given a problem and you start with grams or liters, or let's say atoms or molecules, almost always you're going to have to convert it first to mole. And when you set up the conversion factor, you're always going to start with your given. You're going to multiply it by one of these, what I put in there, these little conversion factors. If you're going from the outside towards the middle, to mole, when you're going to try to figure out how many moles of something, that's going to be on top, moles on the top. And then this one here is going to be, this is molar mass. So you have to find out using your periodic table how heavy does 1 mole of that material weigh. And then when you're going from here to here, you're going to divide by the number. Over here, coming down this way, okay, since we're going to moles, whatever you're going to, moles of compound A over 22.4 liters. That's the kind of the magic number. If you have 1 mole of a gas, it will take up 22.4 liters. Over here, if we're coming from out here to the mole, you want to say 1 mole of that material, and that's going to be Avogadro's number. And I'll just say atoms there, but it could be molecules. So whenever you're going from the outer part here, liters, mass, or particles, almost always you're going to have to convert to moles. If we give you moles at some point, or you've calculated moles, and maybe the problem ends by saying, here's so many moles, we need you to end up with how many grams, or atoms, or liters, then you're going to multiply, okay? Because there's almost always going to be more liters, more grams, and more molecules of a material than how many moles of it you have. So it's just going to be the opposite. Here you multiply by Avogadro's number. And since you're coming from the mole, that's always on the bottom. On these conversions, whatever you were coming from, I mean like your givens, you want to always have, when you're converting, you always want to have the number you're trying to cancel out on the bottom. Over here, molar mass. For example, if this was water, oxygen is 16, hydrogens are each 1, so it'd be the molar mass of water would be 18. Molar mass, excuse me, sorry. Yeah, we're going to be multiplying by the molar mass since we're going this way, and 1 mole, that material down here. And since we're going here, so 22.4 liters. So anytime you're going to the outside part of this MVP triangle, you're multiplying. If you're coming from moles to any of these, you're multiplying by the factor. I call this the given side and the find side. To connect, when you got to convert how many moles or grams, liters, or molecules of this compound, you need to convert it to this one. And we do that by, since we're coming over here, you look to the balanced equation. Look at balanced equation. And so you see how many moles of the, whatever you're trying to find up here. So moles of compound B up there. This is the find, as I call it, over the moles of what you were given. And this chart would be moles of A. And you got to look to the balanced equation for that. And you should always, when you're setting these up, please write your units and whatever the compound is. Write the name, because that way you can cancel out. That's a great way to check yourself. And let's see, how would you use, explain the steps you would use to convert grams of A to liters of B. So what I like about this is when you got this roadmap here, if we're starting with grams of A, okay, compound A, we're starting right there. We'll just call it X grams, okay? And we want to end up with liters of compound B. We want to find liters up here. Okay, so this is where we want to end up. Here's where we're starting. So the first step is, okay, you're going to have to write down however many grams that they give you in the problem. Since we're going to the mole, you want to divide by the molar mass of whatever this compound is. So you're going to write the given. Okay, then you are going to multiply, in this case, by the molar mass. Molar mass. It'll be like grams per mole. That's what the units will be. At that point, you're going to have number of moles because you've done this part of it. Now, we've got to do the mole-to-mole equation here. So now you've got to multiply by molar mass, by the mole-mole ratio, we call it. And that's from looking at the balanced equation. So you have to look at whatever the balanced equation is given in the problem and get those set up. Next, after we do that step, so now we've done this step, okay? We started with our given, we've multiplied by the, did I say multiply by molar mass? Oh, I'm a turkey. No. Since we're going this way, we have to divide by the molar mass. Yikes. So sorry, everybody. Yeah, that's going to be divide by the molar mass. So what that'll actually look like, let's say the given was 16 grams of water. Okay, so now then, that's the given. Sometimes you can just put that over 1 if you like. So when we divide by the molar mass, let me make sure, yeah, there we go. Well, there we go. Well, so the molar mass of water is 18 grams of water over 1 mole of water. Now see here, we can cancel those off. Please always put the units and what you're working with. And this here, okay, now you're going to multiply by the mole-mole ratio. Let's say in this problem, you look it up and, well, let's do 2H2O plus 2 H2s plus O2. This is the common splitting water. So if we were trying to, if we were given this much water, we'd have to look at the balanced equation. There are 2 moles of water in here. So we'd put 2 mole H2O. And then, I don't know, let's say that B was, we're looking for oxygen, okay? Well, in this balanced equation, there's only 1 mole of oxygen. Now, the last step is, now we've jumped across over to here. The question, we want to end up with liters. So now what we have to do is, we want to end up with liters up here. And since we've canceled off here, we want to put 1 mole of O2. Well, for the conversion for that, it's going to be 22.4 liters. So 22.4 liters of O2. So that was just a quick made-up one, but there's the steps. Let's see. Oh, okay, then we got to multiply by 22.4 moles per liter. Excuse me. 22.4 liters per mole. There we go. Get that the right way. Look up there. 22.4 liters per mole. Okay, for both of these, okay, first off, when you're looking for the mass, you have to look on the periodic table. Okay, so let me grab one here. Oh, let me get an easier one to see. So you just have to look up titanium. Here it is. Titanium's mass is 47.8, so we'll round that to 48. So it's 48 grams in 1 mole. 48 grams of titanium and 1 mole of titanium. So what's the mass of 1 mole? Well, it's going to be 48 grams. How about half a mole of radon? Well, radon is over here. Radon's estimated mass is 222 grams in 1 mole. I should say 22 grams of radon in 1 mole. But now here we're saying for 1/2 a mole. So set up the problem. We'll do 0.5 mole radon. And then we're looking for the mass of this. So if we want to come back over here, okay, so we're given how many moles of radon? 1/2 a mole. We want to convert it to mass. So since we're going away from this triangle, we want to multiply it by the molar mass of radon. Oops. So if we're given 1/2 a mole of radon, in there, we got 1/2 a mole of radon, so then, okay, we'll put that over 1. And the molar mass of radon is, we said 222, so 222 grams of radon in 1 mole of radon. Those cancel. I'm not going to calculate it. You can do that. Okay, the molar mass of the following. I'm only going to do one of these here. I'm not going to do them both. So you got to look on the periodic table, and you've got 2 irons. Every iron has a mass of 56. So I'm going to say the mass is 56 times 2 of them, because we have the subscript 2. Plus now oxygen, its mass is 16. And we have 3 oxygens, so I'm going to multiply that by 3. And let's see here, that's going to come out to 112 plus 48. You can do the math. You can do the same thing over there for calcium hydroxide. Okay, now setting up this problem, number 3. How many grams are in the following? Okay, so now we're at grams, okay, and for this, both of these problems here, we're at grams. We're looking for grams. So in this problem, we're given moles on each of those. So since we're at moles and we want to go to grams, we're going to multiply by the molar mass. You put your given 0.25 moles. Don't get lazy. Put the unit, mole, and the compound there. And now we want to convert this into grams, so we're going to say that 1 mole of SiO2. Now you got to look up, you got to find out, okay, what's the mass of silicon? When you look that up, it's 28. 2 oxygens is 32. Comes out to be 60 grams of SiO2 is the molar mass. Okay, and then you can go from there. Now this next one, how many moles are in the following? We're given grams and we're asked to go to moles. So in those problems, we're starting on our MVP triangle down here at grams, and we want moles. So we want to, when we go from the outer to the inner, we always want to divide when we're going towards the moles. We're going to divide by the molar mass. So we're going to set up what's given, 24 grams of CH4, that's methane, put that over 1. And then we're looking for moles, so we just need to say, okay, so we want to end up with moles on the top. We've got grams over here, we need grams of CH4, so yeah, that makes sense. We need to divide by the molar mass. And let's see, carbon has a mass of 12. We got 4 hydrogens, every hydrogen is 4, so 12 plus 4 is 16. Oh, wrong spot. 16 grams in 1 mole. And so now that'll let us cancel out. To get the answer, it's going to be 24 divided by 16. On number 5, we're looking for liters. So if you're still not sure, you come over, we're given moles, we're looking for liters. So we're right here, right in the middle of our triangle. Since we're coming out here to volume, we're going to multiply by 22.4. So 0.25 moles of O2. We are going to say 1 mole of O2 is 22.4 liters. That's how much it'll take up, 22.4 liters of O2. Those two will cancel, and it's going to be, well, let's see, it's probably going to be 1/4 of 22. It's probably going to be, see, half of 22 is 11. It'd be around 5 or 6-ish. You set up problem B the same way. Number 6, how many moles are in the following? So we're looking for moles, and we're given liters on these. So we're going to do just the opposite of what we did in this problem. In this problem, we were given moles and we wanted liters, so we had to multiply by 22.4. This time, we're going to divide by that, because when we're up here at volume, if we want to come down to moles, we need to divide by 22.4 moles per liter. So you've got 33.6 liters. Oh, excuse me, let me get that up there. Oh, let me zoom in some more. Sorry, I just realized this is pretty small. Let me get that a little bit bigger for you. So that's our given. Liters of C3H8. That's propane, by the way. Put that over 1. And we're looking for moles. So we're given that many liters. So we're going to say that every 22.4 liters of C3H8 is going to give you 1 mole of C3H8. And we cancel those out, and it's going to be 33 divided by 22 there. Next one, how many molecules? So in this one here, we're starting with moles, and we're going to molecules. So when we're on the MVP triangle, we're here at moles. We're coming out here to molecules. Okay, so we need to, molecules, look at, if we're asking you for molecules, there's going to be a lot of them. And it's Avogadro's number is the one here. So it should hopefully make sense to you. Yeah, you've got to multiply by Avogadro's number. So let's see, how many molecules? Make sure I got this centered here. So there's our given, 1 mole of H2O. I'm just going to turn this into the given right there. 1 mole of H2O. Well, I'm going to say 1 mole of, excuse me, that's H2, not H2O. 1 mole of H2 gas is going to take up, is going to be 602 hexillion molecules. I abbreviate molecules molex. H2. That lets us cancel out. And there you go, Avogadro's number. The part B, you're just going to multiply that by 3. So on number 8, we're doing just the opposite now. We're given number of molecules, so we want to know how many moles. So if mole is the MVP of chemistry, we're starting here, and we need to go to moles. So we're going towards the middle of this triangle. We're dividing. So we're going to take the given here. Let me get this guy out of the way. Just so I don't want to. So if we got this many molecules, we need to say, all right, 6.02 times 10 to the 23 molecules of C2H6 is 1 mole of C2H6. Now, the molecules of C2H6 will cancel out, and the molecules up there will cancel out. Now, if you wanted to, you could even say, hey, look at here, we got times 10 to the 23 times 10 to the 23. You could even cancel out those, and it becomes 1.5 divided by 6.2. That's going to be somewhere in the vicinity of a, well, anyway, you work it out. But that's how you do it. You're looking for moles, given molecules, you need to divide by Avogadro's number. Okay, number 8, how many atoms of hydrogen are in the following? Now look at here, be careful, okay? Be careful here. We're looking for atoms of hydrogen. So what we have to do is we have to first find out how many molecules. So the first step is first find number, that's not hashtag, of molecules. Okay, now once you find how many molecules you have, you need to just ask yourself, in every one molecule, here's one molecule of this, how many hydrogens are in there? Well, in this, if this is one molecule, there's 6 hydrogens. So I'm going to say 6 hydrogens over 1 molecule of hydrogen. Oh, excuse me, of C3. Okay, that's our. We have one molecule of this C3H6. Every molecule of C3H6 has 6 hydrogens in it. So we got to kind of remember that, okay? So now, if we're starting at moles, whenever we're given moles, 0.75 moles, C3H6. So what we want to do now is, we want to say, okay, 1 mole of C3H6 is Avogadro's number of molecules, 6.02 times 10 to the 23 molecules. Okay, sorry about that. This got in the way. Get that out of the way for the moment. 1 mole of this is molecules of C3H6. So now, at this point, we've converted this into molecules. So what we got to remember is that 1 molecule. Now look, we got molecules of C3H6. Molecules of C3H6. Every molecule, we said, has 6 hydrogens. So now these molecules will cancel out, and those molecules will cancel out. And so what we're going to have is Avogadro's number times 0.75. That'll tell us how many molecules we have of this compound, and every molecule has 6 hydrogens. Now, in this one right here, this is going to be a 2-step conversion, because when we take a look at our mole triangle, MVP, okay, how many grams? We're looking for grams. That's going to be down here. That's our question mark. And we're given 5.6 liters, so we're starting right here at 5.6 liters. So we've got to convert it to moles, and then we've got to convert it to grams. So a two-step conversion, we always start with the given, and then put that over 1. Now we want to convert that to moles, so we want to end up having, we want to say 1 mole of CH4 is 22.4 liters of CH4. Liters of CH4 cancel. Now look, that's an important step. That lets you know you'll probably set this up right because you can cancel those. At this point we're at moles, but we're looking for grams in this problem. And so now what we want to do is we want to say, okay, 1 mole of CH4. Now I set that up because moles of CH4, moles of CH4. And in a previous problem we said, let's see, carbon was 12 plus 4, 16 grams of CH4. And there you go, you're ready to set up. Okay, that's the end of part 1 here. And I'll give it a pause here.